morning, ladies and gents. How are you doing? So, as promised, I'm making this little short video for exercise one, first exercise, and it's part D of it. So, thank you for Jasmine for letting me know that. I didn't really explain how to do it. Now, before I start, just to say that I've never really seen these kind of questions in any test or exam, so it's not really a major thing. But I guess it is in the textbook, so I need to show it, and it's actually quite interesting. It's something that I've learned here as well. So we're looking at how to decide if a certain fraction is a rational number. If we have a certain number, how do we know it's a rational number? Now, the definition of a rational number is, okay, so a number is rational. We say x is rational if it can be written as a fraction of m divided by n, where both m and n are integers. Okay? Integer could be 2 minus 500, 373. Okay? So if you can write, let's say, a number like this, 2 over 5 or minus 7 over 3, these both are rational numbers. Okay? But if you remember, we also said, what about decimal numbers? So I know, for example, that 0.6 is also a rational number. How do I know it? Because it has a finite number of decimal places. The same will be with 0.6125. Okay, that's also a rational number. So there's 4 decimal places. But now some decimals have infinite numbers, like 0.444444444. Okay? And we also learned that because it might be infinite, there's infinite numbers, but because there's a certain pattern, it repeats themselves, 0.44444, we know it's a rational number. But we need to prove it, because the definition really of rational number is that it can be written as an integer divided by integer. So what is the integer divided by integer here? We don't know. So this exercise, which I told you is not really that essential, I've never seen it in a test, will help show you, or will give you an ability to turn this into a fraction that looks like that, a number divided by a number. How do we do it? So 0.4, you know that dot means basically it's recurring. What we're going to do, we're going to multiply both sides, first of all, we're going to write down like this. We're going to say x equals 0.444. Okay? Now we're going to multiply both sides by 10. If I multiply the left side by 10, I will get 10x. If I multiply the right hand side by 10, what happens if I multiply decimal by 10? I just move the decimal place 1 to the right. So it's going to be 4.444, etc. Now, we're going to do something here that we're going to learn properly later on in the year. But here we go. We're just going to show you this. So I've got 2 equations. I've got the first equation, I've got the second equation. They're different equations. What I'm going to do now, I'm going to take the second equation, and from that I'm going to minus the first equation. It turns out I can't do it. Okay? So I'm going to minus the left side minus the right side. So I'm going to write 10x minus x equal 4.444. And it carries on, obviously, minus 0.444, and it carries on, okay? So I can do that, okay? I can minus one equation for another equation, I can add equations, I can do all kinds of stuff like that. Now, the left side is pretty easy. 10x minus x is simply 9x. What is 4.44444 minus 0.44444? Okay, you got to think a little bit about that, okay? Right? I've got 4 minus 0. I mean, what is 4.444? It's the same as saying 4, I'll write it down. It's the same as saying 4.0 plus 0.4444. Okay, I split the 4.44 into 4 and 0.444. But now I need to minus 0.4444. Can you see what's happening here? Well, what are we going to get? We're going to get 9x. These two cancel because it's the same number. Okay, a bunch of 4s that carries on forever with a 0 in the front of the decimal place. And we're only going to have 4. Okay, drop that comma 0. I don't really need that comma 0. Okay, just 4. Alright, and then that means that x equals 4 over 9. So you see what I've done here? I've done 2 things. First of all, I showed you, I proved to you that that 0,4444 is indeed a rational number because it can be written as an integer divided by integer. But more than that, I now showed you what are these integers. So, you know, if you put 4 divided by 9 and put in your calculator, press S and D, you'll get 0,4444. So it's a clever way of finding out, okay, converting from an infinite decimal into a fraction. I'm going to do one more example. All right, so the next example will be something like that. Let's say we have 0,2121 just recurring, okay? We can write it like this, 0,21 and dot on each one of them. So we know we repeat 21, 21, 21, 21, 21. We're going to start the same way. We're going to say, okay, x equals 0,2121. And we're trying to express x as an integer divided by integer and find out what these integers are. So the first stop, to do the first bit, is like we did before, we'll multiply both sides by 10. So we're going to write 10x equals, okay, we're going to have to move it. So it'll be 2, 1, 2, 1, 1, 2, 1, 2, repeating. Now, let's see if we can do the same thing. So if I do 10x minus x, we'll minus one equation from the other. So 10x minus x equals 2, 1, 2, 1, 2, 1, 2, minus 0,2121. Carrying on. Now, the reason why we did last time is that if we do that minus that, we should just get a number in front of the decimal place, a whole number, integer. But in this case, will 0,121212 minus 0,2121, will that cancel each other out? The answer is no. Okay? This, if you look at after the decimal place, the 121212 and 2121 is not the same. So they're not going to cancel each other out. So that is not really helpful for me. It's not helpful. What I've got to do to get rid of that is to time it by 100. So I'm going to find out what is 100x. Timing it by 100, I need to move decimal places twice. Okay? So it's going to be 21.212121, carry on. Okay? And now I'm going to minus, these are the two equations. Let's say this is the first, this is the second, this is the third. I don't need the second. I just wrote it for you because that was our initial thought. But now I'm going to use the third and the first. So I'm going to do the third equation minus the first equation. 100x minus x equal 21.2121 recurring minus 0.2121 recurring. Now you can see that all these numbers after the decimal place are the same, so they will cancel each other out. You're going to get 99 equal, okay, 21.2121 minus 0.2121, it will be exactly 21. And obviously I forgot the x here. And then a quick rearranging, x equal 21 divided by 99. Again, we've done two things. We show that this decimal is indeed rational, okay? And we actually found out what are the integers that if you divide them, you get. Okay, so you need to do these exercises, decide that you're going to multiply by 10x and minus or 100. Sometimes you have to multiply by 1000x. Okay, right, enjoy the exercise.